Good day. My name is Mark Lucchetti, Associate Field Marketing Manager with Wiley Science Solutions. Welcome to today's webinar entitled Introducing KnowItAll Quantitation, Complete and Simplify Your Analytical Workflow. It is my pleasure today to introduce you to our speaker for this informative session, Assistant Editor, Dr. Liana Ergen of Wiley Science Solutions. Dr. Ergen helps create tools for spectroscopy, structural, and scientific standard reference data, and helps create innovative software applications. She completed her PhD in clinical bioanalytical chemistry from Cleveland State University, where she developed a protocol for processing hyperspectral image data that distinguishes the spectra, removes degeneracies caused by symmetry, and is generalized to work with any number of wavelength dimensions and spectra. We are excited to have Dr. Ergen present us today her webinar entitled Introducing KnowItAll Quantitation, Complete and Simplify Your Analytical Workflow. We encourage the audience to submit questions, which will be addressed at the end of this session. With that, I'll turn the stage over to Dr. Ergen for her presentation. Take it away, Liana.
Thank you, Mark. So the agenda for today is first I'll be introducing our new quantitation tool. It's useful for GCMS, IR, Raman, UV-Vis, and GC. After that, I'll be discussing the pain points that a lot of different laboratories experience, and then the value of this software and how it can help overcome a lot of those pain points. Then I'll be talking about who would want to use this software, the workflow that the user would use to accomplish quantitation. Then I'll be giving a demonstration of the software, and at the end we should have time for a question and answer session. So Wiley's KnowItAll has always helped to answer the question of what the identity of a substance is. In other words, qualitative analysis. But with KnowItAll 2024, you will now be able to answer the question of how much of a substance there is. In other words, quantitative analysis. So this is consolidated laboratory software. That means that you don't have to deal with fractured software and processes within your lab. It's intuitively designed with a simple step-by-step process in a single interface. So quantitation is optional in KnowItAll Analytical Edition and JESCO Edition, and it's included in KnowItAll Campus-Wide Solution. So laboratory pain points. A lot of labs have fractured and often out-of-date manufacturer software on their instruments. If that's the case, maybe each instrument has a different software package with a different way of processing and quantifying data, if it has it at all. And it creates this situation where people need to be trained on a smorgasbord of different softwares. It's a huge time commitment to get trained and become proficient in all of the software that the lab uses. So a lot of times people just default to Microsoft Excel for quantitation, and that works fine if everything is done correctly, but that's a big if. So what happens if someone makes an error? What if you need to keep track of who performed what calculation or what changes were made? It starts to fall short. And that makes it very difficult to standardize procedures. So for years, KnowItAll has streamlined qualitative analysis. Now we're streamlining quantitative analysis into the same familiar application. So because all the tools and techniques are integrated into a single environment, KnowItAll makes the analytical laboratory workflow seamless. So KnowItAll for quantitation is currently suitable for GCMS, IR, Raman, UV-Vis, and GC. And we do plan to add more techniques into the future. So quantitative methods include external calibration, internal calibration, and standard addition analysis. So the value of KnowItAll Quantitation tool, a single application across multiple techniques ensures that lab staff can perform quantitation across the lab consistently in one package. So researchers often find themselves navigating multiple software packages. KnowItAll's quantitation tool eliminates that need. With quantitation, there is no need to switch to tools outside of your analytical workflow. There's no need to navigate multiple software packages. If you're performing quantitation in Microsoft Excel, it's a manual process that's prone to error. It's prone to not being able to identify who was doing what and what was done to the files. But with our new quantitation tool, there is no need to navigate multiple software packages because the entire workflow can be done in KnowItAll. So because it's integrated with the familiar KnowItAll interface, it shortens the learning curve and reduces the amount of training that lab personnel need. It is also VPAT 508 accessible, and we are continuously working to improve accessibility. So our quantitation tool offers consistency, time savings, streamlined workflow, reproducibility, reduced training time due to a single software package. This is quantitation done properly and consistently. So who uses quantitation? A lot of people. I'm not going to read through the whole list, but you can. This list is not inclusive, but people who use quantitation would be anyone who wants to determine the amount of a substance. And considering that quantitation is taught in every undergraduate chemistry curriculum, it's worth noting that Wiley offers quantitation at a highly discounted academic rate for campus-wide solutions. So this is the workflow that a user in the software would use, going from left to right. On the left, you see the type of data that needs to be input for external calibration, internal calibration, and standard addition analysis. The blue in the middle is what's done in the software. So KnowItAll quantitation, step by step, is step 1. It plots the signal versus the concentration. In step 2, it derives a calibration equation. You can save that calibration, but at the end, you are given an output. So if your input is external calibration, samples, and known quantity of calibrant, the output of the software is going to be analyte concentrations. If you're performing internal calibration, the data that you input is samples and a known ratio of analyte. The software will output ratios of analyte versus internal standard. And finally, if you're doing standard addition analysis, the data that you input would be samples and a known quantity of analyte. The data that's output is analyte concentration. And now I'm going to be switching over to KnowItAll to give a demonstration of the software. So when KnowItAll first opens, this is what you see. Very first thing we need to do is navigate to quantitation. So I am down here in the bottom left, clicking quantitation, then I'm clicking quantitation again, so I'm now in the app. My first demonstration is going to be external calibration using IR data. So what I need to click is new external calibration. And at this point, you want to navigate to wherever you have your data stored. So I need to select all of the data samples that I want to use for my calibration curve. One caveat here, I'm actually going to unselect the 0.8% because I'm later going to use that as my unknown. So I have selected the 4 data points that I want in my calibration curve, and I am opening them. Now, one of the great things about this software is that when it needs you to do something, it prompts you to do it. So what I need to do right now is enter the range of my calibration peak. The peak that I want is this one, around 1700. Now you can type those numbers in if you want, but you can also just select this region on the calibration bar. So notice that my mouse is over the dark green bar. I'm going to align my mouse, click down, drag over the peak, click up. That enters our peak range here for us. Now I'm clicking next. And I need to answer some questions about the data. I would assume that the user would know what data they're using and could be able to answer these. But target unit, my data is in units of percent. It's asking peak area versus peak height, curve fitting algorithm, and integration method. So if you are okay with what's selected, go ahead and click next. And this is showing my peaks up at the top. In this table at the bottom, I need to enter some information. So here on the left, you are seeing a list of the data samples. And over here on the right, I need to enter their concentrations. So I do have the concentrations in the file names, but 0.2, 0.4, 1.6, 3.2. And I was also clicking enter after each time I typed a number. So just double checking 0.2, 0.4, 1.6, 3.2. Clicking next. So here at the bottom, you can see my calibration curve. You see some statistics at the top of the calibration curve. So R squared, remember the closer that is to 1, the better the fit of the line. Root mean squared error, and equation of the line. So here on the bottom left, you see a list of data that was used to make this calibration curve. But what I want is over here, the bottom right, I need to import an Analyte file. So far I've created a calibration curve. I need an unknown. So remember earlier, I did not use this 0.8%. That's because I'm using it now as my unknown. So I'm clicking the sample, clicking open, and it shows up down here at the bottom left. It's giving me a concentration of 0.76898%. And from here, you would create report, and it would spit out a report in whatever template your lab has created. So for my second demonstration, I want to get back to the quantitation homepage. I'm actually just going to click close on this tab, and no, I don't want to save anything. That brings me back to my homepage. So my second example is going to be an internal calibration using GCMS. So I'm clicking new internal calibration, and it's prompting me to find data. So I need to go to my GCMS data folder, and the samples that I want in my calibration curve are these 4 at the bottom. And I am opening this. Once again, it's step-by-step procedure. It is prompting me with entering data when it wants me to do something. So I need to know a lot of information about my standard and samples when I'm using GCMS. So I happen to know that my internal standard has a retention time of 11.5 minutes. I know its concentration. I know the mass to charge ratio of the ion that I'm interested in. And I also have that same information about the analyte. And I am going to need to enter that information. So this drop-down list that showed up, I actually want to select my highest concentration sample. The 200 at the end, that's indicative of my concentration. So I'm selecting that. And I also want to choose the mass to charge ratio of the ion that I'm interested in, and that is over here in the top right. I'm interested in a mass to charge ratio of 124. Being next in the bottom left. And you might recognize this green bar at the bottom. It says calibration bar. Whenever you see a bar at the bottom with a name, it's basically asking you to select a peak. So yes, I can type the numbers in, but I think it's easier to click down on the bar, drag to the other side of the peak, click up. Those numbers are entered automatically. So now I'm clicking next. So I am interested in the peak with a retention time of 11.5 minutes. In other words, this peak. So I am clicking this little box at the top of it. And I am interested in an ion with a mass to charge ratio, clicking next at the bottom left. And here, notice that I now have this bar at the bottom says internal standard bar. This wants me to select the peak that's associated with my internal standard. And as I said at the beginning, I already have information on hand about my internal standard and my analyte. I know it says peak at 11 minutes. So click down on one side of the peak, drag to the other side, click up or unclick. I'm clicking next. Once again, I have to enter some more information. So units that my data was collected in is micrograms per milliliter. Actually, micrograms per liter. Sorry about that. Peak area, linear regression is my algorithm, and tangential skim. Clicking next. And here I once again need to type in the concentrations of my different standards. So I have them on hand, 1.60 for the first one, 7.99, enter for the second one, 40.0, enter for the third one, and 200, enter for the fourth one. Double check them and click finish. So once again, this should look familiar for the calibration curve layout at my last example. Here I have R squared value, root mean squared error, and equation of the line. Over here I have the data that makes up my calibration curve. Notice this row, I have some X's that would enable me to remove one of these if I wanted to. But import analyte file, now is my chance to import an unknown. So I'm using one of my unknowns and opening it. And this shows up down here, my concentration, 35.157 micrograms per liter. And if you want to create a report, you can create a report. If you want to save the calibration, you can. That's all over at the bottom right. So that's it for my demonstration. Are there any questions?
That was wonderful. That was indeed a wonderful webinar, Liana. Thank you for that. We've reached the end of the presentation today. Thank you, Dr. Ergen, for your time and expertise to present us your talk on introducing KnowItAll Quantitation, complete and simplify your analytical workflow. We'd now like to open up the session to some questions from our attendees, which if you can please type in using our questions toolbar, that would be great. Also joining us today are Dr. Michelle D'Souza and Dr. Nadia Lastruk, both also of Wiley Science Solutions. So let's begin and see what we have coming in here. All right, here's the first one. Do you have examples of IR gas mixtures for quantitation?
I do not currently have any data on hand to show as a demo, but the process within the software should be the same.
Great, thank you. Let's see, we have another one. Will there be future integration for HPLC quantitation?
So currently we have GCMS, IR, Raman, UViz, and GC. I know that in future versions of the software, we do plan to add more methods. Michelle or Nadia, do you happen to know what methods we're planning to add in the near future?
LCMS, Nadia? LCMS. HPLC, we keep an eye on that.
So
we need to read in file formats. So from instrument, we need to read in all those formats. Basically, if we can read in the shared format, then we should be able to follow the similar process to handle it.
Okay, thank you.
Great. Is it possible to have CLS or PLS algorithm?
Okay, those are the multivariate analysis algorithms. Those are good to separate overlapping peaks when the peak, two different components. Right now, we use we follow the Beer's law to do quantitation, and that part will be explored later. The LCS and PLS method. That's a totally different game plan.
Thank you, Michelle. Okay, here's another good question. Is the software 21 CFR 11 compliant and or meets the requirements of ISO 17025 for the integrity of records?
Okay, it's complicated to answer that question. Okay, we are 21 CFR 11 compliant supportive. That means we do not alter records or change anything. And when you generate a report, we put the people can sign signature as well as timestamp, and also the license number who generated. So you always know which machine generated reports. But to be full compliant, if you're talking about the change control, that needs a lot of programming and use tools quite differently. So we're not there yet, but we are very interested and watching the direction into that direction. Yes.
Thank you, Michelle. Okay, how about this one? Can all brand GC data be processed here in this software? Is it a standalone software?
It is a standalone software, but we read in multiple file format. We just calculated, I think we have 130 different file format you can put in. And you can always, GC data, you can always put XY format to go in. And then to use GC, you can even have multiple component. Actually, you can use internal standard to calculate the quantitation, the ratio of quantitation for GC components.
Great, thank you, Michelle. Here's another one. Is quantitation of GC FTIR supported in the same way as GCMS?
GC FTIR, we don't have sample files for that. We would like to see the sample files, and then GCMS make you pick iron, but GC FTIR makes you pick a peak, I guess. So we need to figure out how to proceed from there. Yeah, it may have to change how to pick component a little bit, but it should follow the same flow. We are thinking about following the same workflow.
Excellent, thank you, Michelle. Here's another good one. How are the quantification files stored? Can they be interacted with outside of KnowItAll?
They're stored in a proprietary format. You cannot, right now, you cannot interact outside of KnowItAll, but it's a good point. It's stored, so we know how to export it. In certain situations, you may want to export as an Excel or some data format. So if there's a format defined, it's just to ask to export, so we should be able to support it.
Good, thank you for that. So if we have a little more time for a few more, how about, does KnowItAll Quantitation work with both absorbance and transmission FTIR?
Yes, it does. That's a KnowItAll. KnowItAll works with that. We have a long history to work with them.
Thank you, Michelle.
Mm-hmm.
Okay, we have a few more. Can this software be used for semi-quantitation to apply to every peak, as opposed to calibrating for every component one at a time?
That's a very good question. Very interested in that also. So what you do is you, for TCMS situation, for multiple component, as you can see that example have multiple component. What you do is you generate a multiple component, multiple calibration from that. Theoretically, it's possible. Right now, it's not there yet. Depends on demands. We have to measure the demand and then implement the method. That's a very good question. That's a one stone kills multiple bird plan.
Thank you. Here's another one. Can we create our own library for ourselves with molecule of interest?
Yes, you can. KnowItAll is famous for flexibility in creating user libraries. And one example is not shown here. We do have an example. Check our training document. You can store your library. This is, in this case, a GC files, a multiple component, as a KnowItAll library with the concentration, and then you can transfer certain records to quantitation to generate the calibration, and you can transfer unknown records to be calculated concentration. Yes, you could.
Thank you. We might have time for maybe one or two more. How about, so quantitation software can be really challenging to use. What does KnowItAll do to ensure the usability of the software?
So the software uses a step-by-step dialogue. Basically, when the user needs to do something or input some data, something pops up on the screen asking for that in some way. So it's pretty user-friendly in that way. And there's also a lot of training documentation online. I was actually following along with some of the training documents for quantitation that are posted on our website for the demos today.
Great, thank you, Liana. I think we can potentially get one more in there. Can we define our own report templates with the software?
Yes, you can. So within KnowItAll, you can design a report template for your lab to use so that your reports can be standardized every time.
Thank you. Maybe we'll sneak one more in here. Can multiple or variable EV ionization be utilized in this software?
That right now is no. Yes and no. Okay, depends on how you store the data and then analyze data. So it's not as simple as just a one EV situation.
Thank you, Michelle, for that. Well, I think we've reached the end of our time today for the questions. I'd like to thank Assistant Editor Dr. Liana Ergen of Wiley Science Solutions for taking the time to present us her talk on introducing KnowItAll Quantitation, complete and simplify your analytical workflow, as well as Dr. Michelle D'Souza and Dr. Nadia Lastchuk for their time and expertise with our Q&A. Any questions that were not addressed will be answered by email if able. This presentation will eventually be available for on-demand viewing on the Wiley Science Solutions website at sciencesolutions.wiley.com in the webinar section. Thank you very much for attending and enjoy the rest of your day.